previous experience with R. So if you have never worked or seen R before, this will be a video to get you introduced to the software. The course, or this video in particular, will focus on simple data analysis such as reading files, modifying and summarizing data, and statistical analysis. And my goal here is for you to learn enough about R so that you're able to follow the material in my econometrics course and to do your own R estimations for your classes and research projects. So before we proceed, please go to my website and download the R dataset and the program from my website. These are the topics that we will cover in this video. First, I will talk about the R website and downloading R, or the R project software. Then I will talk about RStudio, or a very user-friendly interface to work with R. Then I will talk about the advantages and disadvantages of R. Then we will talk about the programs or the R program file that have an extension .r. Then I will talk about the R console, where the commands are listed and the results are shown. We will also talk about reading different data files, particularly the CSV files. We will talk about importing data with the statements read and attach, summarizing and analyzing data using the command summary, sort, table, and correlation, and then statistical analysis using t-test, ANOVA, and regressions. Finally, we will talk about how to install and use packages, which we will use a lot for the rest of the course, and using help. So before we begin, I will show you how to download the R software. If you're in Google, just Google R or R project and you will come to this website. And the way to download R is right on the front page. You will see here getting started and downloading R, and you can just click on that and go to your CREN mirror, which for me is in the US, and there's several choices. I pick this one. You can pick whichever one you want. Then download R for your system, and I clicked on download R for Windows, and then under base, and then install R for the first time. So this will get you started. You just download and follow the commands. If you go back to this website, it also has very useful information on different packages, and also there's help, manuals, and so on. So it's nice to take a second look at this website and see what it has to offer. Now you can also download a user interface called RStudio. And if you go and Google RStudio, this is the website that you will find. And you can say download now and download RStudio desktop, and then follow the commands to install that. And RStudio is a very user-friendly way of working with R, which is a lot more helpful, I find, than working in the R itself. Okay. So here, after downloading and installing the software, if you click on the R icon, this is what the window that will come up. This is the R software, and you will most likely see the R console, which will be blank for you. This is where the results are executed and the output is echoed. And if you open here, you do File and Open Script, you can look for the program that you have hopefully downloaded and saved on your computer and open it here. And you can highlight all of the program and click on here, which is Run Liner Selection, and you can have the whole thing executed. And this is what you will see for you. But instead of using R, I will be using RStudio. So if you go ahead and now click on RStudio, this is what you will see in your window. There will be 4 windows, and I have rearranged them here a little bit to improve visibility for the video. But you will have a blank file called untitled, and this is where you will put your program, where you will write code and save your program. And for you, probably right below it, and I put it here to my side, is the R console. So when you're executing programs, the output is going to show up here. And on the side, in my bottom, you have here the workspace and history, where you can check on the data and see what commands you have executed. And here you also have, with files, plots, packages, and so on, you have additional information. So the first thing to do is go ahead and download my program, save it somewhere on the computer, and then use File and Open File, and find where you save the program on your computer and open it. And I've already opened it, and here is how it looks like. This is the introduction to our program. And what I have done in order to execute it, you can highlight line by line and then hit run here to execute the program, or I have highlighted like that the whole thing and executed it, and these are all the results, so that I don't do it slowly and we're ready to discuss it. So the first thing to notice about our programs is that some things are in green, and if you put the pound sign in front of any line, this means that it's a command that gets ignored. And this way I can put comments here and things that would be helpful to explain the program. So the first real command here is set working directory, and I have saved all my files on my hard drive in the C econometrics data directory. So wherever you have saved your file, you can go ahead and change the directory to the folder that the program is saved in, and this way you can read data sets and from there. And you need to put there all your data files as well, so that the software can find it. So the next thing to do is read the data, and to do that, because it's a CSV file, you do it with read.csv, and here in parentheses you put the full directory where your file is located. So you can only include part of it if you have set your working directory, or you need to put the full thing if you have not set the appropriate working directory. And this is what I have done in this case. So once you read the data file, you call it a new name called my data, and you assign this name to it. And then in order to be able to use this file, my data, you need to attach and then the name of your file, my data. And now this file is part of the memory. And if you would like to look at the file, you can go to workspace right here and see all the data that's in the memory. And if you double click on my data, you will see it right here. And this is the data that we're using at the moment. So the data here is on automobiles, and we have 26 observations, different cars, different makes. We have the price, the miles per gallon, repairs, weight, length, and whether or not a car was foreign. And this is the data set that we will use for our example. Going back to the program, we can, first of all, we can name the variables or list them by using names and putting the name of the data file. And these are the names: make, price, miles per gallon, and so on. These are the headers, the variable names. The next thing that we can do is we can show the first few lines of data by using head my data, or my data from 1 to 10th row, comma, and all the columns. And so we're getting just the first 6 observations listed here, and then the first 10 observations for the next one. The next thing we can do is summarize the data using summary, and then you put in parentheses the name of the variables that you want the summary of. And here's the results here. You can do summary of miles per gallon, And here's the median, mean, and so on. You can also calculate the standard deviation, the length, and then you can repeat that for summary of price and the standard deviation of price. And these are the results that we get for the descriptive statistics. The next thing that you can do is sort the data, and you can sort it by, say, the variable make. And here is how it's sorted now. The next thing you can do is frequency tables, and we will do this by using command table, and then we would put the variable names here for make. And so here would be the results: table, make, and then you have for AMC is 3, odd is 2, and so on. So this is a frequency table of the data. The next thing is you can also calculate a table for make and foreign. And here now the frequencies, if we have for foreign equals 0, which means a domestic car, and for foreign equals 1. So you have the frequency in all these categories by make and by foreign. You can also calculate correlations among variables, and you use correlation, and then you put the two variables that you want to calculate correlations of, in this case price and miles per gallon, and we see that we have a negative correlation. Higher the price, lower miles per gallon right now for this example. Next, you can calculate a t-test comparing the means of one group to a number. And to do that, you're using t.test, putting the name of the variable here, comma mu equals to 20. This will be the null hypothesis. And here for the results, you have a one sample t-test with miles per gallon, and we have the t statistic and the p-value, which is greater than 0.05, and then we have the conclusion that we cannot reject the null hypothesis, that it's significantly different from 20. Okay, the next thing is to do ANOVA for equality of means for two groups. And you can do this by saying ANOVA, LM for linear model, and this will be a dependent variable miles per gallon, and the factor would be foreign. So we are comparing miles per gallon for the two groups. One is domestic and one is foreign. And the variable for that is foreign, a 0, 1 variable. And here again, you can look at the p-value of this test, and you can see that this p-value is slightly below 0.05, which means we have significant differences in miles per gallon between domestic and foreign cars. The next thing we can do here is estimate an OLS regression, and here miles per gallon would be the dependent variable, and weight, length, and foreign would be our independent variables. And here we would have the linear model. You put the name of the dependent variable, and then R requires this squiggly part to be, instead of like an equal sign in the regression, and then you list all of your independent variables with a plus sign, and this is how you execute an OLS model. Now that you've executed it and you gave it the name OLS reg, you can summarize these results and point them out here. And these would be the results, and you can say that the higher the weight, then we have lower miles per gallon, and the higher the length, we have higher miles per gallon. Lower miles per gallon, and so on. You can interpret those the results. You can also alternatively, instead of just estimating a regression, assigning it a value, and then summarizing it, you can put summary in front of the results, and this way it's going to show you the results immediately. The next thing we can do is plot the data, and you can plot miles per gallon against weight. And when you execute this code, you can see that in the plot it will be out here. And so we have here the weight and the miles per gallon on the horizontal and the vertical axis. Another thing that you can do is also estimate the linear model, with weight being the dependent variable and with miles per gallon being the dependent variable and weight being the independent variable. And you can estimate an AV line, which is the regression line. So here's the regression line coming from the regression model, and this is the original plotting of x against y, and you can see the regression line. Okay, so the next thing that we can do, and I'm using this a lot in my class, is by redefine variables. And the reason why I'm doing it is because I may have some variable names in my example of the dependent and independent variables, and you will have different ones for your problem. So I find that students are usually confused about which is a variable and which is a command, and what could change in a program when they learn a program and how it works for the first time. So that's why I prefer to work with y and x. And in order to do that, for miles per gallon, I am using the cbind command into a y variable, and weight, length, and foreign, I'm using cbind into an x variable. And once I do that, we can summarize y and x, and you can see the results here with miles per gallon, and with x, all the variables. And we can also run an OLS regression using linear model, and you put y versus x, and then we summarize it, and we see basically the same results that we saw before. So this line of code right here is the same as this line of code right there, only that it's more generic, so that when you get a program from me, all you have to do is change here your dependent variable and the independent variables, and hopefully the rest of the program should run for you. The final thing that I'm going to show you how to do is install and use packages, and we will be using this in almost every program, and that's how R operates. It has very little programs internally stored, and you will have to download the package from the website, and so that you can use it for your statistical analysis. So you can install packages by just removing this pound sign and running the code here. Or another thing that you can use is from here, packages, and then install packages, and then you can look for it, PLM, and once you get to it, you can click install, and that will install it on your machine. And once you have it installed on your machine, then you need to run the code library PLM, and then this would put it now in the memory, and so that you can use it as part of the program. So this was an introduction to how to do R, and what I have shown you here, I will use this for the rest of the course. R is a very user-friendly program, and it has many advantages. The first one is that it's free. You can download it from the website. It works anywhere in the world, and that's a really good thing. And it also can do a lot of the econometric models that we will do in this class, and that's also an advantage. And then there are so many packages that people are contributing that you can use in your work if you know how to use R. The only disadvantage, I think, is that perhaps it's a little bit harder to use if you have never used it, and also that typically it comes without much warranty for whether or not these packages work and how they work, because most of the time they're user contributed. But I would consider these disadvantages very small, and I would strongly recommend to you that you learn how to use R, and we can use it in the class. Thank you for watching.